respected deans, head of the departments, faculty colleagues, my dear students, and other participants. Good afternoon to one and all. This is Josna Devi Bodapati, Assistant Professor, Department of CSC, Vignans, deemed to be University. On behalf of the Department of CSC VFSTR, I welcome you all to this webinar. On behalf of all the participants, I take it as a privilege to welcome our esteemed speaker, Dr. Thimothy Gosalves. Sir, good afternoon, sir. As you all know, Department of CSC VFSTR has been successfully organizing a series of webinars on the recent research developments for the benefit of the students, faculty, and research scholars. As part of this, we have so far conducted a few webinars like evolution of artificial neural networks, learning to deep learning. Then we had another webinar on natural language processing, then another on security in digital payments. So recently we had a webinar on deep neural networks for sequence-to-sequence modeling. Now, it gives me immense pleasure to welcome you all to today's webinar on data science and application perspective by Dr. Thimothy Aloysius Gosalves, Professor Emeritus and former Director, IIT Mandi. So coming to this webinar, we all know that data science is a multidisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured and unstructured data. The term data science was actually coined in 2008 by Dr. DJ Patil and Jeff, heads of analytics and data at LinkedIn and Facebook respectively, to describe the emerging field of study that focused on teasing out the hidden values in the data. Now, data science has evolved as a discipline that spans around programming, statistics, data mining, machine learning, analytics, business intelligence, data visualization, and host of other related subject areas. Data science has become an essential part of everyday life and emerged as a critical component of modern business intelligence in recent years. Recognizing its importance in both academia and research, we came up with data science as a subject for this webinar. Now, I request our beloved HOD, CSC, Dr. D. Venkateslu, to speak few words on this occasion. Sir, could you please?
Thank you, madam. So, as I already said, so I just for this for the information of the participants. So Professor Thimothy Gosalves, I was the first PhD student of Professor Thimothy Gosalves. So he was the founder director of IIT Mandi for a period of 10.5 years, and he was also head of the Department of Computer Science and Engineering, IIT Madras, for a period of more than 5 years. And he was the co-founder of the TNet group, and he also set up a company called Nilagiri Networks based out of OT. So the key objective of the TNet group is to develop an indigenous communication technology for the welfare of our country. The sir and his team used to think all the time to develop the low-cost solutions for the development of our country, rather than importing the technologies from other countries, which is very expensive. So I had I have a long association, maybe more than 30 years of association. So I'm very much grateful to you, sir, to accept our invitation and to deliver a webinar on the data science. Thank you very much, sir, for accepting our invitation and invitation to deliver a webinar. Thank you very much, sir.
Thank you, sir, for sharing your views. I myself feel it as a great honor to introduce our legendary speaker, Dr. Thimothy Gosalves. So Dr. Thimothy received BTech in electronics from IIT Madras in the year 1976. He received MS from Rice University in the year 1979. He received his PhD in electronics from Stanford University in the year 1986. Then he joined with WPI, Massachusetts, USA, as an assistant professor and worked there till 1988. Then in 1989, he joined with IIT Madras and served the department in various positions, including head of the department. Most notably, he was the founding director of IIT Mandi in the Himalayan state of Himachal Pradesh from 2010 to 2020. He is currently Professor Emeritus at IIT Mandi. In addition to the academic roles, he has been the co-founder for Nilgiri Networks, NSM Works, TNet Group, and many more. He has executed numerous R&D projects successfully. In addition to that, few patents he has few patents with his name and close to 100 publications in prestigious journals and conference proceedings. In his career, he received many awards for his services and contributions. His students call him shortly Tag with a lot of love and affection. So these are only to mention a few. So we are really fortunate to have a stalwart like you with us. And I feel one must be fortunate to listen to your lecture, sir. So I thank Dr. Thimothy Gosalves for accepting our invitation and being here with us as a speaker for this webinar. So without any delay, let's listen to our speaker. Now I invite Dr. Thimothy Gosalves to take over the session.
Thank you, Dr. Venkateshlu, for the invitation and for the introduction, and also Dr. Jyotsna, thanks for giving a good overview of what is data science. And also, I was interested to hear about the webinars that you've been conducting recently, since they cover a lot of the underlying technologies of data science. What I'll be talking about today is not going into depths of technology and so on, but to try to give a broad picture of why AI and data science have become important of late, and particularly I'll talk about applied AI. This photograph you see here is some of our students. When they're not studying, they do things like going hiking in the mountains, playing in the snow, and so on. So AI it's a term that is used a lot, particularly in businesses and marketing and so on. And perhaps one could say that it is misused a lot. So from an academic perspective, we could say that AI has, there are three aspects to it. One is the core fundamental technical base of AI, the foundations, things like how do you represent knowledge, how do you reason with knowledge, how do we understand cognition, and so on. Secondly, AI is applied to a number of fields. For instance, there's things like vision, there's natural language processing, Internet of Things, and so on. And now these fields are then applied to specific applications. So the type of applications that we're familiar with, such as when you go to an online shopping site, you get recommendations. We have prediction of weather, and so on and so forth. So these are the different aspects of AI. Now, AI has been around from the 1950s onwards. It started with the Turing challenge, where Alan Turing said that a measure of machine intelligence is when you can have a conversation with a machine and not know that you're talking to the machine. You think you're talking to a human being. So that was in 1950. A lot of the early work in AI was working on the core of AI, and the one question that one might ask is, why is it that technology that has been there from 1950s is now beginning to get prominence, and everyone is talking about it now? Why not earlier? Yeah. Can you all hear me clearly? Is there any issue?
Yes, sir.
Yes, sir.
Yes, sir.
And you can see the slides clearly.
Yes, sir.
And on the second slide, what is AI? Yeah, okay.
So AI timeline.
Yeah. So as you can see from this timeline, I won't go into details, but you can see that from 1950 till for about 15 years, there were developments in AI. The term AI was coined. There were some interesting programs like ELIZA, which did medical diagnosis of a very rudimentary form, and so on. Then from 1966, for about 30 years, there's what people call the AI winter, where the early hopes of AI did not materialize, and many people felt that AI is a lot of hype, and so there was not much progress. In 1997, IBM came up with Deep Blue, a computer that could play chess. And then after that, from 1997 onwards, there have been developments. And as you can see in the last decade, or last maybe 5 years, there have been a lot of developments in AI. And there are tools that we use every day, like Facebook, Google search engine, and other things, all of which depend on AI today. So one question that I'll be addressing in this talk is, why is it that AI, which was proposed in 1950, did not take off at that time and is taking off now? What are the changes? And then we'll also talk about some of the projects that are being done in AI here at IIT Mandi to give you an idea of what academic institutions can do in this regard. Now, the promise of AI is becoming a reality largely because of a few fundamental laws of computing and some technology trends, which I'll cover over the next maybe 10 minutes or so. The first law is Moore's law, which was proposed in 1970 by Gordon Moore and from Intel. And in that, essentially what he did by empirically looking at the number of transistors on a chip, he predicted, or he found that every 1.5 years, the amount of hardware on a chip doubles. And this prediction that he made in 1970, now 45 or 50 years later, it still holds. As you can see from this trend over here, that this is plotted on a log scale. So on the log scale, it is linear, which means that there's actually a doubling every 1.5 years. So from 2,000 transistors on a chip in 1970, by 2016, we had reached nearly 6 billion transistors on the same chip. Okay, so this is a tremendous improvement in computing power. And also, of course, as the power goes up, the converse is that the cost of computing goes down. Now, thanks to Moore's law, these integrated circuits are used not only in computers, they're used in communication devices and so on. So thanks to that, today we have almost universal availability of wireless network connectivity, even in remote places of Himachal Pradesh. We went to, if you go to Lahore, Spiti and so on, which are high altitude tribal areas, even there you get internet in most places. However, the internet today is shared, and the actual bandwidth that a user may get may range from a few tens of kilobits to hundreds of kilobits per second, and network failures, congestion, and so on are common. Now, taking Moore's law, if we look at the effect on communications in the next, say, 15 years, it's predicted fairly conservatively that everyone will have at least on the order of tens to maybe 100 megabits per second of dedicated wireless bandwidth in about 10 to 15 years. And so there'll be a sea change in the availability of bandwidth. There already has been quite a significant change, going from internet being available only in a few organizations, big organizations and cities, to internet today being available almost throughout the country and throughout the world. Looking at the impact of Moore's law on computer hardware, again, what we've done here is an extrapolation, taking a pocket-sized cell phone in 2015, a Lava 356 phone, and you see the specs of the phone over there. And we've extrapolated based on Moore's law alone, nothing else, what the same cell phone would look like in 2035. And you can see that from a single core CPU, we have an 8,000 core CPU. So you can have 8,000 different applications running at the same time on your cell phone. So what you do with it is another matter. Similarly, you can see that the network bandwidth available goes from 100 kilobits per second to 100 megabits per second. We have the cost remains practically the same. The amount of memory also shoots up. Now, effectively, if you look at the specs of this device in 2035, it is equivalent to about 8,000 of today's laptops. So you take all the laptops in a large academic institution, shrink them into a wristwatch-sized device, and that is what every baby born in 2035 will get when she's born, and will keep for the rest of her life. Okay, so you can imagine the computing and communication power that will be available to people in the near future. This is within the lifetimes of all our students and with many of us also. So that is one important law, and these are the implications. A second interesting law, this is again Metcalfe's law. This is again an empirical law. There's no formal proof of this. Bob Metcalfe was one of the early inventors of the Ethernet and the Ethernet LAN that we use today. So he predicted again back in 1970s that the usefulness of a network is proportional to the square of the number of users. So if you have a network with 10 people connected, and you get a certain benefit out of it. If you have, say, 20 people connected, you'll get 4 times the benefit. If you have 100 people instead of 10, so 10 times the number of people, then you get 10 squared or 100 times the benefit. Okay. Now, some people have applied, have looked at Facebook and Tencent, which is the Chinese equivalent of Facebook, and they've computed the usefulness of the network in some way. You can find the details in Wikipedia. And as you can see, they have found, in fact, that Facebook and Tencent seem to follow Metcalfe's law in terms of usefulness. So this is a second important law. And one of the implications of this is what we see today, that when we have a large social media network, and we have a choice between a big one and a small one. Now, which one do you use? And if you have a choice between using Facebook and, let's say, some college graduates come up with a new, some new competitor to Facebook. Now, Facebook has, say, 500 million Indians are on Facebook. The competitor has maybe 100 users on it. So which one will you use? If you take 500 million, which is n, so 500 million squared versus 100 squared, then it's obvious that you'd use Facebook, because Facebook is far more useful. So what this Metcalfe's law has done essentially is to drive the development of a very small number of social media networks and so on, which have dominated all others simply because their n is larger, and therefore their n squared is much, much larger. So that people gravitate towards the largest. They gravitate towards Google, towards Facebook, towards, say, Instagram for photos, and so on, and all competitors die out. So this is a second fundamental law. And as we go forward, I'll explain why these are important. But a third law that underlies the rise of AI and data science is something that has been there for a very long time in statistics, namely the law of large numbers. And essentially what the law of large numbers says is that if you take a population and you look at the distribution of any characteristic, you take, say, the height of people in of a group of people, or you take the intelligence, or you take the any such characteristic. Now, and you plot it, and as the number of people in the population increases, the distribution becomes closer and closer to a normal distribution. And once you have a normal distribution, then you can calculate the average and the standard deviation and percentiles and other such things. Okay, so if you have say 2 people, one person may be very tall, one may be very short, or both may be very tall. If you have 10,000 people, then pretty much the height, there may be 1 or 2 exceptions, very tall and very short people, but on the average, they will be the height will be normally distributed. So this is a very interesting thing. Now the result of this law of large numbers is that if you have enough data about a population, then even a computer can do predictions about that population, because given a large amount of data, the average, the standard deviation are known. And once you know the average and standard deviation, then you can make predictions. What is the probability that you'll find certain number of people greater than, say, 6 feet tall? What's the probability of having, how many people are likely to be less than 5 feet tall, and so on. These can be done. And because of this law, the predictions will be very accurate. And so these are things that machines can do. So in fact, this law of large numbers really has driven the rise of machine learning, which is one aspect of AI, where a machine takes a lot of data, learns from it, and then makes predictions about the future. Okay, so, and as long as you have enough data from a population, then the predictions will become more and more accurate. Okay. Okay. Now, so as I said, Moore's law. I looked into we looked into the future and saw what kind of device we'll have in 2035. So just to recap, for since many of you have not seen the development of computers, back in the 1950s and 60s, computers were very large. A computer would occupy a large room or a hall. They were called mainframe computers, and they were standalone. There was no connection. If you wanted to take data from one computer to another, then typically it would be printed out on a sheet of paper. Then you go to the other computer, type it in over there, enter it over there. So that was how things were done. In the 1970s, again, thanks to integrated circuits coming in, computers became much smaller, say the size of a microwave oven or a TV, not a flat screen TV, but this shows I'm a bit out of date. I talk about big bulky TVs. So the size of a big microwave oven would be or a refrigerator, that would be a better example, was a mini computer. These again were standalone. In the 1970s, the internet, the networking started, and by the 1980s, there were some mainframe computers in universities and so on that were connected by a network, but a lot of computing was done on PCs about the size of a microwave oven or a bit smaller than that, and these PCs were largely standalone. By the 1990s, networking had become sufficiently inexpensive that most PCs were also networked, and people started, and in fact PCs became more and more powerful due to Moore's law, and so a lot of computing was done on the PCs rather than on mainframes and mini computers. And from 2000 onwards, as you know, we have small mobile devices which are as powerful as the PC of the 1990s, and these have access to computation, data, and so on in the cloud. Okay, so this is briefly how computing has evolved over the last maybe 50 or 60 years. Now, apart from the three fundamental laws that I talked about, there are some technology disruptions which have contributed to the rise and success of data science and AI. One of these is the so-called Internet of Things. In the past, when we wanted to monitor the weather, say the Indian Meteorological Department, IMD, would set up weather stations. Each weather station costs tens of lakhs of rupees, and given the cost, these are typically set up in a district headquarters in a major town. And if you look at India, weather stations, IMD weather stations are typically 25 to 50 kilometers apart. So we know the weather very accurately at the weather station, but if you go 5, 10, 15, 20 kilometers away, then we don't have much idea of the weather. Now, of course, on the plains, you may be able to interpolate. In hilly regions, or if there are forests coming in the way, then the weather can vary quite drastically. Today, you can buy inexpensive weather stations for just a few thousand rupees, and these come with network connectivity, so they can be put in a field and they connect to the internet and start uploading data straight away. They are easy to deploy, very inexpensive. Every farmer, even an individual house owner, could afford to have such weather stations. Now, these IoT weather stations are, of course, less accurate compared to the IMD weather stations, but it is possible that if you have large number of readings, again, based on the law of large numbers and so on, we can use statistical techniques to improve the accuracy of these inaccurate devices. Yes. They can also be calibrated against the IMD weather stations that are nearby. So we find the same trend has happened in many other areas, in many other types of sensors. For instance, whether you take GPS, web cameras, motion sensors, accelerometers, and all sorts of things. Again, 20 or 30 years ago, these would have cost lakhs of rupees each, and each would have been the size of a refrigerator. And nowadays, if you take even a simple cell phone or a wristwatch, it has perhaps 10 or 20 of these sensors incorporated in it, and they cost just a few, some of them are just a few hundred rupees or less. Not only has the cost and size come down, but again, unlike the earlier weather stations which required a diesel generator and source of power, the new sensors often can run on batteries or solar power for extended periods of time without any connectivity to the electrical grid. So the result of these technology disruptions is that now we have sensors not only monitoring the weather, but when structures are built, say a bridge is built, and sensors are incorporated in the steel girders. When an engine is made for a vehicle, there are sensors in the engine which are constantly collecting data. And all this data which is being collected continuously is being fed through the communication network that we talked about and is now available globally. So that it's not just available locally, but there's data collected throughout the globe about almost everything under the sun, and this is available to designers, to engineers, to data scientists, and so on. In fact, even there's a lot of data being collected about human beings. Many people nowadays have either their cell phones monitor their movements, or they have these smart wristwatches, or what are they called, Fitbits and so on, which monitor heart rate and pulse rate and other things. And again, this data is put on the cloud and then is available. So other technology disruptions that have happened in the last couple of decades, cloud storage and computing, where rather than having an organization having its own computer servers and storage, storage and computation is available in the cloud from various commercial vendors, even from governments and others, so that anyone, anywhere can have access to the computation and the data. One of the advantages, particularly in the case of data science, as I said, machine learning works provided we have access to a large amount of data. So if data is put into a cloud storage, then it becomes available to people from anywhere in the world, so that we do have access to large amounts of data. And finally, in machine learning, there's been a lot of development of particular machine learning algorithms, and many of these have been developed in universities, some in industry, and many of these are now made freely available in languages like Python and so on, so that even high school students or college students who have very little knowledge of the details can actually apply these machine learning algorithms and get some useful results out of them. Okay. Yeah. So we've seen over here that there is a hardware trend, thanks to Moore's law and so on, which has made possible the collection of vast amounts of data and this data being put onto cloud servers and made available to data scientists who want to use it to make predictions or other things. Now, there's been recognizing the value of this vast amount of data, many engineers and scientists have in fact moved away from earlier when one wanted to say design a bridge. There are equations that govern the deflection of the beam under load. You have a beam and you have load on the bridge. Then the deflection is governed by certain equations. And earlier engineers would use these equations, solve them, and decide what kind of a beam do we need for a given load. Now there's a new way of designing, say, a bridge that, let's say we have many different bridges of different sizes, shapes, and carrying different loads, and all of them are equipped with sensors. Okay, so as vehicles go over the bridge, we can measure the weight of the vehicle and also the deflection of the beam. Now if you want, so given this vast amount of data about the behavior of bridges in actual practice, if we want to design a bridge for a certain number of vehicles per hour, we just look for in our data for some bridges that match that pattern. And once we find a bridge that matches that pattern, we use that design for our new bridge. Okay, so now I may be simplifying things a little, but this is the way that that a lot of engineering and science is evolving, from being driven by deterministic solutions, by equations, and so on, to looking for patterns in data of existing engineering solutions. This is also being used in science. For instance, in material science, nowadays people are beginning to use data science to design new molecules, that rather than the approach used by chemists in the past or material scientists. They look at the characteristics of many existing molecules and materials, and then figure out what kind of molecular structure will give some desired properties in a new material. So this is known as computational material science, which is getting popular nowadays. In fact, it's interesting that last year at IIT Mandi, probably for the first time, we started teaching data science and Python to MSc chemistry students. Normally, MSc chemistry students may not even learn programming, so here we teach them data science and Python programming. And some of them have found that when they apply for PhD positions, this is a benefit because chemistry researchers are looking for chemistry PhD students who understand data science and Python programming, which is quite a change from the past. So we've looked at some of the fundamental laws and technologies that have led to the rise of data science and of AI. In some sense, one could say that data science is the applied part of AI, of machine learning part of AI. So one definition of data science from Wikipedia is application of scientific processes, algorithms, and systems to extract knowledge and insights from data in various forms. Now, to give you an idea of what is involved in data science, for instance, if you want to apply data science to, say, the weather, the first thing we need to do is to collect a lot of data about the weather. So we'll have weather stations in different parts of the country. We collect data regularly from those. We need to figure out how accurate the data is, and all this is part of the data collection process. Some data, there may be errors, in some cases there may be missing data, so we need to take care of all of this. Once we've collected the data, we can do some analysis. For instance, we can try to fit some model, fit a curve to it, do a regression analysis, and see does the temperature or whatever vary according to some distribution. Now, once we've done the data analysis and got an understanding about the behavior of the data, we can now make some inferences. For instance, we might find that there is an impact, an effect of say the time of day on the temperature. What's the impact of the time of year on the temperature, and so on. And finally, after coming up with some inferences, some predictions of the future, this has to be communicated. Communication is not all that straightforward because, for instance, when you apply statistical techniques, there's always inaccuracy involved. There are always probabilities involved. When we talk to people, and if you give a number, say the temperature tomorrow is going to be say 23 degrees, people will expect it to be precisely 23. Now, it is actually 23 with a probability plus 23 plus or minus 0.5 with a probability or confidence of 95%. Now that is not something that the general public really understands. So how do you communicate the results? That's also part of data science. Jim Gray, one of the pioneers in databases, has termed data science as the fourth paradigm of science. The first paradigm was the empirical, where people like, for instance, when observing, say, the falling apple led to the theory of gravity. Then the next is the theoretical. For instance, like Einstein's theory of relativity was the theoretical development. Computational has become important in the last few decades, and now data science is the next paradigm of science. So some of the successful examples, good example of data science and applied AI. The first few are ones that are well known to all of us. For instance, in social media, when you upload a photo, often, or even if there are several faces in the photo, often Facebook will identify the photos even before we do and ask to tags the photos. We have, when we do online shopping, we get recommendations, and again, very often we find that the recommendations are things that we actually wanted. And based on our past behavior or what other people have been doing, people who have similar likes and dislikes to us, the online shopping applications are able to come up with quite good recommendations. Web search is something that we all use, and whatever search engine you use, when you enter a term, for instance, if you enter a term, say, what is data science, there are probably maybe 100 million pages in the internet that have these words, what is, and data science in them. And yet, almost always we'll find the search engine gives us, in the first page itself, in the first 10 hits, you'll find very relevant hits. So how is it that a program software is able to pick out the 10 relevant pages from 100 million pages? That's something really amazing. And these are everyday examples of the success of AI and data science. Engineers and scientists are using data science in more and more ways. I'll talk about some aspects here at IIT Mandi in medical diagnosis and prediction of landslides in agriculture. As I mentioned, civil engineers and mechanical engineers are using data science in design of structures, in weather prediction, in design of molecules, and so on. For instance, recently one of our graduates who joined Tata Motors, a mechanical engineering student, his work is essentially collecting data about truck engines that fail, and then from the data about that, figuring out why they fail. So again, he collects all kinds of data, like who's the owner of the truck, which district is it running in, what load is it, when was it made. There are technical and there are social sort of data about the vehicle that he collects, and all of this they use to see what is. Some of it has an impact on the failure. So talking in medical image processing, several years ago, some faculty at IIT Mandi got interested in seeing how they could apply image processing techniques to help people who are suffering, particularly people in villages. Now, so they looked at this question of detection of cervical cancer cells, and there what is done is that a photograph, a micrograph is taken from the cervix of the women, and then this is typically inspected by a radiologist who will then say whether there's likelihood of cancer or not. Now, since the majority of our population live in villages where there's no equipment and radiologists and so on, the question is how do we take this to the villages? So our faculty tied up with a Bangalore-based company called Aendra, and they worked with some doctors in various hospitals. And after several years of effort, Aendra has come up with these portable scanning devices that you see in the left and center. So these take the image, and then there's image processing software which comes up with the picture that you see on the right, where there are some potentially cancerous regions that have been detected and highlighted by the software. So these machine learning algorithms which are used to do this screening are developed here at IIT Mandi. And what is done is that in the village, then any patient who has this potential cancerous tissue will then be asked to go to the town or city for a more detailed observation. Of course, most of the women would not need to leave the village at all. So this is one way in which, in an academic institution, some of these new developments in data science and AI are being used to help people in rural areas. A second application which is quite important in the Himalayan region, it may not be all that important in Vignan, which is in the plains areas, but over here, as you can see in the Himalayan region, there's landslides are a major problem. You can see here a landslide, a big area of a hill, which is sliding down, and there's a village down below, which is in great danger. Every year during the monsoon season, a lot of property is damaged, and of course, many lives are lost. Now, the property may not be able to be saved, but at least lives could be saved if we could predict at least a few minutes or maybe half an hour in advance that a landslide is likely to occur. For instance, there was one case where some buses stopped at a tea shop during the monsoon season, and there was a major landslide, and 2 buses with all the passengers and the tea shops were all covered by the when the hillsides slid down. Now, if they had been given 5 or 10 minutes notice, they could have left that area and would have been saved. Now, if you look at the engineering of a landslide, behind a landslide, we have the soil has a certain strength. And as soil gets moist due to rain, the strength goes down. So as the soil moisture content increases, the soil strength decreases. And once it reaches a certain low level, due to the weight of the soil itself, the boulders, the trees and other things, you get a landslide. Okay. So now, the way that traditionally engineers study this is that there's something called a triaxial machine over here, in which soil samples are placed, and then moisture is placed and pressure is applied to it, and then we get a stress strain curve which shows how the soil behaves as the moisture conditions vary. So that based on this, then engineers can, if they do some measurements, they can figure out that there's going to be some potential of a landslide somewhere. Okay. Now, so the problem with this approach is that when you do the experiments in the lab, it's fine because you have a homogeneous sample of soil, you apply moisture to it, and one can make predictions. However, in real life, the soil is not homogeneous. There are different types of soil on the hill slope. There are different types of load. There are trees in some places, there are bushes somewhere else, there are buildings elsewhere, there may be boulders here and there, all of which cause uneven loading. Now, there is also stress that as you have vehicles going on nearby roads due to the vibration of the heavy vehicles, again there's stress on the soil. So if you try to model all of these using traditional techniques of differential equations and so on and so forth, it becomes just too difficult. Okay, there are too many combinations of these different variables, too many, and so it cannot be easily predicted using traditional techniques. So here is where data science can play a role, that if we collect a lot of data about the movement of actual hill slopes, let's say we place many sensors on the hill slopes and collect data about the movement of the hill slopes under different weather conditions, different times of day and so on, and then this can be used to predict when there's going to be a landslide. And in fact, this is what has been done by a startup company from IIT Mandi called IoTs, where they've developed a low-cost device for sensing landslides and giving a prediction. These devices cost about 20,000 rupees each, so they can be deployed. In fact, they have been deployed in large numbers in parts of Mandi district and have, in fact, given warnings before some landslides, and thus saving some possible loss of life. A second major area that we're working in is in agriculture. Agriculture, as you know, is the backbone of a large number of Indians in rural areas. And agriculture is not doing very well because of declining prices and rise of the produce and rising costs of inputs and so on. Now, if you see how agriculture was done traditionally, there was people had had knowledge. In fact, traditionally, the monsoons were quite predictable. Every year, from a certain time, we'd have monsoons with a certain amount of rainfall and so on, and there was not too much variation from one year to another. So if you see that the farmer typically would, based on the traditional knowledge from his father, his grandfather, uncles, and so on, they would know very. Yeah, was there some question?
No, sir, it was some interruption from the audience.
Yeah, so farmers would know when to plant, what seed variety to plant, how much fertilizer to apply, how much water to apply, when to apply pesticides, when to harvest, and where to market it. So all this these patterns were repeated year after year after year and worked very well. Now, this is no longer working well for two important reasons. One is climate change. With climate change, monsoons are no longer predictable. The amount of rainfall may vary, and also the pattern of rainfall varies. And it varies from year to year. And this is something that it's very difficult, particularly for small-scale farmers who don't have a lot of resources and are not highly educated, to understand. The second factor that has changed dramatically is globalization. Earlier, a farmer would be competing with other farmers in the same region, in the same district, or maybe the same state. The markets also were local. Whatever was sold locally. Today, an apple farmer in Himachal is competing with apple farmers in New Zealand and in China. Potato farmers in UP are competing not only with potato farmers from Punjab and Karnataka, but also with potato farmers from Ireland and China and Russia. So because of globalization, imports are quite common, and farmers, of course, also have the opportunity of exporting. So these are changes. Now, here again, these are things that a small-scale farmer without much education, without much resources, cannot handle easily. Okay, so then what is the farmer to do? So this is where this idea of precision agriculture is being developed. Okay, so here what we have is that we have the crop, and we collect a lot of information about the crop, not only from this farm, but from many other farms. We collect information about the soil, the nutrients in the soil, and so on. We collect information about the pesticides that are being applied, fertilizers, this information about the seed varieties, information about the weather, and then we also collect information, say, about the prices, and not only the prices locally, but the prices in other parts of India and the prices abroad, about the production abroad. If there's a glut of production abroad, then no doubt prices in India will go down. So all this information is collected, and given that, say, we have 100 million farms in India, if we collect this kind of information about all 100 million farms, then we have a vast amount of data available. Okay, and given this vast amount of data, clearly we can try to apply data science algorithms. Okay, so this is the idea in precision farming: collect a lot of data about different types of farms, different farming practices, and so on, and then use these to advise the farmer on how to manage the crop, what seed variety to plant, in fact, even what crop to plant. For instance, a farmer might have the choice between planting potatoes, carrots, or peas. Now, which one should he plant? That will depend on the yield and the price of these three potatoes, peas, and carrots, say 3 months from now after they're harvested. So this kind of prediction can be done by data science algorithms. A small farmer without much knowledge is not likely to be able to do it. So these are some of the things that are done in precision agriculture. And 2.5 years ago, the Department of Biotechnology started a major national project called the Farmer Zone, and IIT Mandi is leading that with other partners from India and elsewhere. So the goal of Farmer Zone is to apply machine learning algorithms to help small and medium scale farmers to make better crop management decisions. Currently, we are working with potato farmers from Himachal, Punjab, and UP, and in the future, Farmer Zone will expand to about 20 major crops and the whole country. So to give you some idea of some of the techniques being used over here, one of the issues in potato cultivation is blight. And you get blight, as you can see, the blight burns up the leaves, and then that affects the growth of the plant and the growth of the potato tubers. And so it's important to be able to predict blight before it happens. Once the leaf is burnt, nothing can be done about it. But fortunately, given the weather conditions and other things, it's possible to do some prediction when blight is likely to occur, and then the farmer can apply pesticide or do something to prevent the blight. So what is done here is that we are doing some using image processing, take some photographs of the leaves, then apply some various transformations and come up with different transforms based on that image. Then these are fed into different layers of a deep learning neural network model, and then leaves can be classified as either ones that are free of blight, or ones that are likely to get blight, or ones that already have the blight. So this classification and detection can be done, and then this can help the farmer. Something else that Farmer Zone is doing is to make predictions based on weather. So over here, what we do is that the predictions are specific to a particular location. The weather in a certain area is taken, the soil conditions and other things, and then based again on machine learning type of algorithms and models, the predictions are made. For instance, there's a prediction for Indo-blight forecast, when the farmer should plant, and so on. Here we've done, of course, as yet we don't have good data on how effective these things are. However, there have been some studies in the literature that indicate that if farmers follow such advices, then the productivity could increase by anywhere from 25 to 90%. So that would be the kind of benefit that the Farmer Zone project can bring to small and medium farmers, provided, of course, that they follow these. This is a work in progress where we are still to verify that these increases in productivity actually will happen. So I've given you a few examples of actual use of data science in an academic institution here at IIT Mandi, where in all these cases we are working with industry and with actual users, whether it is doctors detecting cancer, or the highway engineers who are trying to predict landslides, and the police, the traffic police, or farmers who want to improve their productivity. There are some other such projects going on here, which I won't talk about. Now, machine learning sounds fine, and it looks, some people say AI is the solution to everything, and in future we won't have a need for human intelligence, and so on and so forth. I'd just like to talk about some issues with AI and data science that we have to be aware of, particularly researchers and engineers in this area. The first is AI and machine learning are essentially based on developed models of the behavior of some system based on the input, the data that is input. Now, if the data that is input is inaccurate, then the output is inaccurate, will be inaccurate. One good example of this is the COVID, and there are people who tell us that COVID was going to end in June. It didn't actually end. There are people who tell us it'll end in November. Someone else says it'll end in February next year, and someone else says it'll be with us for the next 5 years. Okay, now all of these are given by models, and they're all using data. Now, the reason they come up with such widely varying answers is partly because the input data is inaccurate. Okay, there's very limited testing done, so the number of cases that are being reported is probably a small fraction of the actual number of cases. Now, when you feed inaccurate data into a model, the model will. Okay, the model cannot. So this is one serious issue with data science, which is often neglected. It's easy to take a Python machine learning, write a small Python program, use some machine learning algorithms, feed data into it, and get some prediction out of it. But if the data is inaccurate data, then the prediction is worthless. So that's one of the important areas that data scientists and computer scientists need to focus on in the future. How do we ensure that this vast amount of data that we are accumulating is in fact correct? Or to put it another way, what is the accuracy of the data? Is it, if you have temperature measurements, is it plus or minus 1 degree? Is it plus or minus 10 degrees? Is it plus or minus 0.1 degree? And then some data will be more accurate, some is less accurate. A second major issue in machine learning is that machine learning is based on the data that is provided. And there are cases where this becomes a kind of, there's a reinforcement cycle over here. One example where machine learning has, there's been a bit of a backlash is when trying to use AI for policing by police forces, both in, especially in Western countries, but also in India. In many of these countries, as you know, there is a bias that dark-skinned people are more likely to commit crimes and so on. And so police will question them more, and there'll be more data about criminal-minded dark-skinned people in the database. Okay, so now the AI program will tend to identify dark-skinned people as criminals. Now, since the dark-skinned people know that they're being identified as criminals, when they see a policeman coming, they will react negatively. So this becomes a vicious cycle. That, and in fact, this is in the West, particularly, there have been studies of this, and in some places, AI has been they've stopped the use of AI in policing because of such biases. Okay, so this is something that is. There is what's called the learning bias, and this is well known in machine learning. By experts in machine learning know this, but the general public may not know this. So here it is very important to have real experts in the area who can say when the AI is suffering from learning bias, and then can correct the learning bias. So, and again, real experts are few and it's difficult to come by. So this is a serious issue that needs to be addressed. Another important issue that when people talk about AI taking over the world and AI taking over various professions and so on, then the question is that earlier people worked in these professions and they no longer have jobs. For instance, one profession that is a large number of people work on today is teachers. Now, it may be in the future that with AI, that teachers are no longer needed. People learn from online courses. There are automatic question banks which test people, and as they get tested, they are given grades and so on. So why do we need teachers? So a lot of teachers may go out of business. And this is true of photographers, journalists, and others. In fact, it's even true of, if you think of, say, a neural surgeon who's going to do a surgery in the brain. In the future, what will happen is there'll be a tiny microbot which will be inserted into your, say, blood vessel, and then it'll go through your blood vessels into your brain, and it'll be communicating with the server, with the surgeon, and the surgeon will control it and and perform the operation without actually cutting anything open. Now, what will happen in future is that this microbot will start talking to a server, and the instructions for doing the operation will come from a server and not from a surgeon. So maybe that even surgeons go out of business in the future. So in this new world where data is key, where data is the sort of new oil and is the new wealth, who owns the data? Who benefits from it? Either you may not know it, but every time you click on a link in almost any website, within seconds, the fact that you've clicked on something is being sold by the server to advertisers, merchants, and others, and they are all making money on the fact that you have clicked once. Okay, this is, and we don't get any money out of that. A few years ago, Facebook bought WhatsApp for $19 billion because WhatsApp had 500 million users. Now, the owners of WhatsApp, a few tens of people, got this $19 billion. And the 500 million users who actually provided the basis for that sale got zero. So these are examples of how vast amounts of money are being made out of data, and the people who generate the data, the people whose data it is, are getting practically nothing. The people who run the servers, Google, Facebook, and others, get most of the money. So this again is something that needs to be addressed by researchers and by policymakers and all people, and not just the owners of the servers. In 1993, there was this nice cartoon which appeared in the New Yorker, where there are these two dogs, and one dog is telling the other, on the internet, nobody knows you're a dog. You don't know who's typing at the other end. Now, with data science and machine learning, that is no longer true. That even if you try to keep data about yourself private, it's very easy to figure out things. Just to give you a simplistic example, supposing when I'm traveling, as we travel, my cell phone connects to various towers. So the cell phone company, the telecom operator, can keep track of where I go. Okay. So now I decide that I don't want anyone to know where I'm going, so I turn off my cell phone. Okay. Now I turn off my cell phone after I get into the car and or the bus, and of course the driver of the car or bus has his cell phone on and keeps it on all the way. And so with machine learning algorithms, it's fairly straightforward to figure out that my cell phone, at the time it was turned off, it was close to another cell phone, and at the time it's turned on after 4 hours, again it's close to that other cell phone. Therefore, I must have been close to that cell phone all the time. Okay, so that's one example by which it's fairly easy to deduce the information about a person, even if that person tries to hide the information. Okay, and this is just a simplistic example. There are a lot more sophisticated ways of figuring out information about an individual, even if the individual tries to remain anonymous. There's something called differential privacy and so on, various techniques which researchers are working on, which we hope may solve some of these problems, but this is a serious issue today. One other important issue is that as we depend more and more on machine learning algorithms, and these are used in, say, driving vehicles, in hospitals, looking after patients, in all kinds of life-threatening situations, then if there is a bug in the ML algorithm in the software, and let's say large numbers of patients die or there are a large number of accidents, who is liable for this? Is it the software engineer who wrote the code, in which case probably people will stop going for software jobs, they'd rather go for something else? Is it the company that sells the cars? So who's liable? Again, there's no answer today. These are things that policymakers need to work on. Okay. So I've talked about machine learning and data science and why these have become important now and why they'll become even more important in the future. I've also talked about some of the R&D projects being done with industry at IIT Mandi. I'll spend a few minutes before I wrap up on talking about what IIT Mandi is doing to help train engineers for this new world where data science will be an important part. One thing that we have done here is that we have changed our BTech curriculum to include project-based learning throughout the 4 years. So every year our students work on interdisciplinary team projects. For instance, in the first year they do reverse engineering, in the second year they work on product development, and the third year they work on technology and society, and in the fourth year they work on a major technical project which is done in most other engineering colleges. So there's a lot of teamwork here. There's learning while doing. There's taking the needs of society and developing practical solutions to the needs of society. To give you some examples, in the second year, all our students go through a design practicum in which at the beginning of the semester they have to choose a problem, such as say a prepaid electric meter, a gas leak detector, and so on. By the end of the semester, they must have designed and built a working prototype and demonstrate this in an open house. So here you see a gadget that is an automated cooker. There are various ingredients at the top. The recipe is fed into this, then the ingredients are taken automatically, the onions are chopped and so on. They fall into a frying pan with the oil, they get cooked, and something comes out of it at the end that can be eaten. And this actually was working by the end of the semester. Here we have a 3D printer built at a cost of 25,000 rupees by second year BTech students. The Spider-Man outfit on the right is made with the household vacuum cleaner and some tubes from some car tires. And this student was able to climb a 15-foot wall again at the end of 3 months of work by second year BTech students. In the third year, our students work on the interactive socio-technical practicum. Here, they look at the social impact of technology. They go out typically into villages around in IIT, see what are some of the needs of the society and how can new technologies help. And they do a sort of technology impact study. For instance, one issue is that Himachal is a largely rural population with large number of villages, and almost every village has a primary health care center or a secondary health care center. Now, how does the chief medical officer sitting in the district headquarters know what medicines are available in each village? How does he make sure that the medicines are properly stocked? So they looked into that kind of a problem. With our emphasis on real world, giving good training for the real world and the future world to our undergraduates, we recognized a few years ago that data science was becoming key to not just computer science, but to all engineering disciplines, including mechanical engineering, civil engineering, and even the sciences. So about 3 years ago, we started introducing data science to all BTech students in the first year. Instead of teaching them C programming or Java or C++, all our first year students in all engineering disciplines are taught Python and data science in the first semester. By the end of the first semester, they can actually work with data sets of millions of records. In the second year and second semester and third semester, they do probability and statistics and machine learning, again with a lot of hands-on lab work using Python. In 2019, we became the first IIT to start a BTech in data science and engineering. And interestingly, this BTech program is, in terms of popularity with new students, it's second only to computer science and engineering. Okay. So what I talked about today is started with describing a bit about artificial intelligence, and then we looked at some fundamental laws and technology developments in computer science, computing, maths, and statistics, which have driven the rise of AI and data science for many applications in the last 5 to 10 years. We see that the Moore's law has driven the development of computers from mainframes to clouds today. The software techniques have gone from sequential programs to parallel programs to, again, cloud computing today. And all these put together, along with the vast collections of data due to very inexpensive devices, has led to many successful examples of the use of machine learning, such as search engines, face recognition, and so on. At the same time, there are still a lot of challenges ahead. I talked about some of them, namely the accuracy of the data, the privacy issues, and various other such issues that need to be addressed. We have also looked at some AI-based projects at IIT Mandi and how our curriculum is evolving to prepare our students for this future where AI and data science will become a key part of all engineering disciplines. So I thank you for your patience, and I'd be glad to answer any questions or discussion at this point. Thank you.
Students?
Good afternoon, sir.
Sir, please proceed, sir.
This is Professor Janardhan Rao. In fact, I am very happy to listen to you for the second time, sir. Gosalves, sir. My son is at your IIT Mandi studying second year BTech data science. And actually, when I got a link, I wanted to know from you, especially the applications of data science and everything and prospects of the people in this particular field, because most of the institutions, they are coming out with AI and data science in this academic year. And can you elaborately tell what are the future aspects of the students who have chosen this field in the coming 4 years? Thank you, sir.
Yeah. Yes. So the question is, what is the potential for the students who want to work in data science? As I mentioned, data science is becoming important in all areas of engineering and science, and this will become more and more important in the future. So there'll need to be experts who understand the different aspects of data science. Some of the challenges, as I said, are in the data collection, figuring out whether the data is correct, how accurate it is, doing the analysis, inferences, and even in presentation of the results, communication to the public or to the decision makers and so on. So there's a lot of, in all these areas, there's a lot of work that needs to be done. So there is good scope both for those students who want to go on for an academic career and do research. There's also a very good scope for those who want to join industry and develop products. As I've shown you some examples of medical image processing and civil engineering and agriculture and so on, data science is being used. We're starting to use them. Now, in order for these to be these kind of products to scale and work well for the whole country, there's a lot of work to be done, and that will require a large number of data science engineers.
Any questions from the other participants? Please feel free to ask. Hitesh Reddy, would you like to ask any question? Because you are muted.
The faculty members, those who are doing research in the area of machine learning or artificial intelligence. So if you have any questions.
Hello?
Yes, proceed. Please proceed, Ram.
Yeah. Thank you. This is a very good informative session. And we request you to provide some startup companies on data science. Those startup companies working on data science. Can you provide some information And please provide some guidelines to establish some startup company to do some research on data science. Especially as you said, the agriculture field, we require some of the lot of research to be done, right, sir?
Yeah. So if you're interested, there are two things you can do. One is in agriculture, we have, as I said, the Farmer Zone project. So the faculty member who's in charge of that is Dr. Srikanth Srinivasan. So he is actually working with some startup companies in agriculture area. One is in Bangalore, another is in, well, there's a more established company in Maharashtra, and there are some startup companies here in around IIT Mandi. So if you look up on our website, Dr. Srikanth Srinivasan, or if you send me an email, my email ID is tag@iitmandi.ac.in, then we can give you more information. IIT Mandi has a business incubator which supports startups. It's called IIT Mandi Catalyst. So if you look up IIT Mandi Catalyst or contact them, then they would have, you can see the list of startup companies that are being incubated by them. And quite several of them are applying data science to various problems like agriculture, tourism, and other areas.
Okay, thank you, sir.
So this is the time you can utilize this opportunity.
Good evening.
Yeah, Hitesh, proceed.
Sir, actually, I'm interested in robotics. How we use AI, machine learning, and data science in robotics? Can you please explain that, sir?
Okay, so your question was about robotics, right?
Yes, sir.
Yeah, yeah. So see, robotics, robots are trying. Yeah. So yeah, so robotics, in robotics, we're trying to replace human workers by machines. And initially, robotics was used for very well-defined, say, assembly line activities. Say, if there's some part which has to be cut to a certain shape, then now as time goes on, robotics are being used for more and more ill-defined type of activities. For instance, in the case of precision agriculture, some people are working on robotics to, you have a robot which moves through a field, then it has cameras and so on, so it can sense the condition of each plant, and then depending on the color of the leaves, the dryness of the soil, and so on, for each plant it can decide how much water to apply, how much pesticide or fertilizer to apply. This is the type of thing that in the past human farmers and gardeners would do. That they would look at individual plants and then give specific care to each plant. So in the future, agricultural robots will do this. The way that they will do this again is by using machine learning. So as robotics moves away from just very well-defined assembly line type of tasks to more ill-defined, poorly defined tasks, then machine learning and data science will be key to successful robotics.
Thank you, sir.
Yeah, any other questions from the participants? Faculty? So would you like to share your feedback otherwise? Suganya, please proceed. Unmute yourself. Please unmute. You're not audible.
I forgot it.
Okay.
Nothing but ma'am, nice sessions we had. The sir told actually he started from the base, but he elaborated a long like a kids he thought. So I like to thank him for that. Only I just on the video. Ma'am. So much kind of him. So thank you. Ma'am.
Yeah, thank you. I'm glad you liked it.
Thank you. Thank you.
Thank you, Suganya. Anyone else would like to share your feedback, especially if you have any questions to the speaker, honorable speaker? Hemant sir?
Also feel free to tell me what you did not like so that I can improve my talk in future.
No, thank you very much, sir, for giving us the entire information from the beginning 1950s to till date. We are also given the future how the cost will be reduced for those devices. Thank you very much, sir. And we are also got the inputs of what are the different areas we are able to work. One is the medicine field, and another one is the agricultural field. And we will work with our students and try to do the projects. Thank you very much, sir, for your valuable information.
Thank you.
Thank you, Hemant sir. Any others would like to share? Or would like to ask questions? Suvarna madam, Nirupama madam, Gandhi sir, Upal sir, anyone else? Certain. I'll wind up the session with a few closing remarks, sir.
Sir, yeah,
Sir,
madam.
please,
Yeah.
you proceed.
Sir, we have a good team of faculty members, those who are working in the area of image processing and machine learning, and also the computer vision. So they've been doing very well, but only problem at this point in time, we are unable to consolidate or identify one particular problem, and which could be presented to the, for which the solution could be presented to the national agencies like DST or maybe a DBT, and get some kind of the project. So that is the one of the areas where we are not too strong actually. We also have biotechnology department over here, and they have been doing very well, and they have the projects also. I informed them about this farmers zone. So what is the work that is going on under the umbrella of the farmers project, sir? So this is where where we need some kind of support.
Yes. So in this, there are two things that I can suggest. One was to have some collaboration with one of the IITs. It could be IIT Mandi. It could also be the nearby the IIT, I suppose, the Hyderabad or Madras, which are close by,
Yeah.
and then proposals. The other is that when you're working on projects, proposals, look for industry or the needs of the surrounding area. So if you're in, say, an agricultural area, then try to see what are the needs of the farmers over there, and try to come up with some pose that as a problem. If there is some particular industry in your area, again you can pose that. For instance, one of the things that I'd heard in some parts of AP, there's a lot of contract farming, and the contract farmers don't have much knowledge of farming because they don't come from traditional farming families. So things like farmer zone and this advisories for them is much more important. Say in Himachal, many of the farmers have been farmers traditionally for many generations, so they have less. Their needs are different. So look in your area and see what are the local industry, agriculture, and so on. Maybe ask the district administration what kind of problems they face, and if you come up with take that as the driving factor for the project proposals you make.
Yes.
Then it's likely to get funded, and also it will benefit the society if the project once the project is done.
Yes, sir. Thank you very much.
Sir, one of the participants is asking, could you please suggest us the online resources or books for machine learning using Python and
Yeah. Actually, offhand, to be frank, I'm not an expert in machine learning and so on. So I think there are others who, I'm sure some of your faculty members would be able to answer that question better. But again, if the participant, whoever it is, sends me a mail and he says what background it is and what level, then I can I'll ask someone and reply to that.
so anyone else would like to ask any questions? So if not any, so we'll proceed with further formalities. Sir, thank you very much, sir, for your informative presentation. So thanks for sharing your knowledge with us without holding it back with you. So especially the applications you have quoted where data science could be used to solve various regional problems like prediction of landslides in advance, then pharma zone where farmers can use it, then detecting the diseases in the potatoes. So they were kind of very informative, and I hope they serve the purpose of, I hope all the participants got much information about where data science could be used to solve various problems. So I hope today's speaker, Dr. Thimothy Gosalves, has explained various recent open research problems in various domains, including civil, biotech, mechanical engineering, and also pharmaceutical. Especially, sir, I am kind of impressed with the case study that you have shared, how data science could be used for the construction of bridges. So like how a civil engineer can also use this data science. So I didn't know, I'm not aware of this earlier. So it was really kind of very informative, I felt. So I hope this lecture generates more interest in data science and inspires participants to work towards the applications of data science with renewed vigor. On behalf of the organizing committee, I thank all the participants for joining this webinar. I hope the webinar served its purpose. We are extremely thankful to our chairman, Dr. Lau Rattegaru, who directed us to organize a webinar with Dr. Thimothy Gosalves. We are extremely thankful to Dr. MYS Prasad, Honorable Vice Chancellor, Dr. Raghunathan, Registrar, for providing all the support required in organizing this event. Also, I would like to extend my special thanks to our Honorable Speaker, Dr. Thimothy Gosalves, for handling a kind of challenging to present a webinar or present a topic. So to various levels of participants, like we have students here, then faculty, then research scholars. So even then kind of he gave a lot of information, which is very useful to the layman and also to the active researchers. So everyone benefited, I hope everyone benefited from this webinar. So I thank Dr. D. Venkateslu, HOD CSC, for his enormous support. And without his support, we could not have been organized such a webinar with such an eminent person. Sir, Thimothy sir, would you like to share your views on this webinar?
Yeah.
Well, thank you for giving me this opportunity to talk to you all. And as I said, I would very much have preferred to be there in person. And maybe next year I'll be able to come and visit and meet you all. And we can have more discussion over a cup of tea at that time.
Sure, sir.
Sir, yesterday I met our honorable chairman and I gave the the webinar, the pamphlet, and he told me that when are you going to invite your guide to visit our campus? So he was very much excited after going through your resume, sir, and it seems he told me in front of the vice chancellor and other administrators. There are two aspects he liked very much. So one is reverse engineering, and the second aspect is taking the students for a trekking during the Sundays. He said these are the two things which are very much. These are the two things which he was very much excited to see. So those two aspects actually in your profile. So he also warned us: you people always keep the students away from you, but see how the director of the Mandi is taking the students to for trekking. So you also have to have such kind of the practices. So this is what the message he gave, sir.
Okay, thank you. I'm glad to hear that. And you can take your students trekking around there, and also maybe during summers bring them to Himalayas.
Yeah.
The IIT Madras has a hiking and trekking club which brings students to the Himalayas.
Yes.
Okay.
So thank you very much, sir, for joining and giving the very nice webinar on data science applications. So I'm very much grateful to you, sir, for accepting our invitation and delivering this excellent talk.
Yeah, thank you. It's been my pleasure. And again, as I said, I look forward to meeting you all in person.
Oh, thank you, sir. Thank you very much, sir. We'll be waiting for you, sir. Yeah. Madam?
Yes, sir. Once again, I
Okay,
thank
so
all
thank you.
the participants for attending this webinar. So I once again take it as an honor to thank our today's legendary speaker, so Dr. Thimothy A. Gosalves. So thank you, sir. Thank you very much for sharing a lot of information with our participants. Thank you once again.
Yeah.
Thank you, sir.
Thank you. Okay.
Thank you, sir. Yeah.
Thank you.
Yeah.
Bye. Bye.
Yeah, bye, sir.
Bye, sir. Sir, one second, sir. Shall we have a photo together? So I request the participants to open their video so that we can have a photo with our speaker.
So video is locked, madam. So you unlock it from your side.
Yeah. No, sir. They themselves can do that.
My video is locked.
Okay. Yeah, because that time. Sorry. Yes.
Yeah.
Hello, sir.
Yeah, madam.
Hello, madam. So welcome to Principal Nirula Institute of Technology, Radhika Paturi.
Madam, you want to
Thank
speak?
you for joining with us, ma'am.
Madam, you want to speak with sir?
No, sir. I'll talk
I
to
asked her actually personally.
So,
She
yeah.
joined at the end, sir, basically.
Yeah, we'll meet. So next year, the beginning of the next year, sir will be. We'll invite sir to visit our campus physically. So at that point in time,
Sure, sir.
we can
Sure.
meet. Yeah.
Okay, sir.
Yeah.
18019. Please open your video if possible. Yes, sir.
Yeah.
Thank you all. Thank you, sir.
Yeah, thank you, sir.
Thank you.
Yeah, thank you.
So please share your feedback. I have already shared the feedback link. Once again, I'm sharing with you. Yeah, with this, I'll close the meeting. Thank you all.